This conference will now be recorded.
Right. So yesterday we were talking about what DevOps really is, and we were understanding what are the tools that Azure DevOps really offers, or what are the services that Azure DevOps really offers out here. And today we said we will start with something called as a repository. Repos. And I'm specifically talking about a service called as an Azure repos out here, or a repository out here. Again, where do you find this service? If you go into dev.azure.com and sign inside DevOps, which I have already done, I'll create a new project. I'll say 8 a.m. sample project, something like this. I'll say the type of project is private. I'll say create this out. And as and when I create this particular project out here, it will take like a minute. And in the left hand side, if you expand this out, there is something called what? Repos. And this is what I want to get into. And again, repository is a space on the cloud. Very importantly, it's just a space on the cloud. Just understand this. In order to store your files. When I say files, it can be your code that the developer is writing. It can be ARM templates. It can be PowerShell scripts. It can be all those things that you can go ahead and store it on the cloud. ARM templates, PowerShell scripts, whatever you think of. All these things that you can store on the cloud or on the cloud here in the form of a repository out here. Then how do I create a repository? Let's see, how do I create one? Yes, it's a storage purpose. Then how do I create one? So if you go into the repository out here, you have something called files. Just click on files. And as and when you do that, Azure enables you, or Azure gives you, let's say, an initial repository out here with the project name. So that's the project name that you see, and it's also creating a repository with the project name. If you don't want this out here, you can click on this particular drop down, say new repository, and I'll say something like a demo repository, and I'll say create. As and when I create this out, I have a repository called demo repository, and there is something called what? Main. This is called as a branch. We'll talk about what this is. We'll talk about what really branch is. Under a branch, you have what? A file. A simple file that Azure gives you, readme.md. MD is a markdown. That's a markdown language that it's written in. And here MD, here it just goes ahead and let's say gives you some general instructions. So some file to begin with, your repository is giving one. And also, now if you click on, let's say this one, repositories, you can say manage repositories. And if you don't want a repository, for example, I don't want this repository, I can do a right click here and say delete. So deleting a repository is also possible. And here you have the name of the repository. Delete. You can go ahead and delete my repositories as well using these buttons out here. So I can say drop down manage the repositories. So if I go to files, I have drop down manage the repositories out here. I can delete my repositories as well out here as such. Good. So one question that a lot of people ask me is that yes, a repository is a very good space to go ahead and store your files. But even my local machine does the same. It goes ahead, stores the file on that particular local machine. Then how is the storage on the repository different from what is your local machine out here? Very first difference, basic difference is that if my local machine crashes, it is very difficult for me to retrieve that particular file. Let's say I have thousands of files and my system has crashed. It's difficult for me to go ahead and retrieve my data. If it's a cloud, there is a general, let's say, let's say trust that the files are available, the code is available, so that even if your system crashes, right, you can go to someone else's system, get that entire code from the cloud because it's a link that you can access this out from. That's one thing. Second thing is very, very important difference is, let's see this. Let's go into my PC and let's go into one of the folders out here and I'll just create a file. Okay. So what I'll do is I'll say new text document, some random name out here. I'll say this is a sample. Take this out. So I say this particular file, and if I just close this out and I open this document once again, I'll have this called, or I have this text called, this is a sample out here. Let's say I add one more line telling this is a sample 2. I save this out, close this, open this out. You see this is a sample 2 out here. Let's imagine you come after a month and see this particular file and look at this particular line, this specific line, and can you probably identify after a month who's added it, when they added it, what time they added it, and why did they add it? Or if they deleted this out, can I know what line was deleted, which line in that particular file was deleted, or which line in that particular file was edited, modified? Really difficult to, let's say, really comment out. But on a repository, all these things are tracked, which gives it a name called as a version control system. Version controlling. There is something called version controlling. That's the main purpose of a repository. So repositories are also called SCMs, source control management, or VC, version controls. What does it really mean by that? Let's see. I have this file called readme.md file. I'll just go and edit this out. I'll just say adding a line in one out here. And in a repository, right, we don't do a save. We do a commit. We call this as a commit. This the thing that you, let's say, do on a file is a save. On a repository, the same file it's called as a commit. I'll say commit. And as and when I do a commit, it's telling, okay, fine, add a comment to your commit. Meaning, what do you want to do exactly? I'll say I am adding line 1. Let's say commit this out. Now it's telling, okay, fine, line 1 is added. Here I added a line 1 out here. And in the history, I have all these being tracked, telling when did I add, what did I add, and going further, we can also see why did I add that, who asked me to add that, and so on and so forth. So if I click on this particular history, do you see there's a difference here? In the left hand side it is telling what was not there. In the right hand side it's telling, okay, fine, there's something which is added. If you remove, it will also tell there is something that was removed, so on and so forth, and it will also tell you the exact timestamp when it was added, when it was removed, and etc. All these things are tracked in the form of something called as commits. And this is called as a commit history. These are all called as what? Commit histories out here. Just give me a second, sorry. These are all called commit history out here as such. So all these are commits that you can go ahead and add out, and all these commits are tracked in the form of a history called as a commit history as such. And also, if you want to look at your commit history, in the left hand side there is something called commits. You can go here, and even here all the commit history is being tracked. So an excellent version control, whatever you edit, whatever you do, you can also control how you can edit, who can edit, and all that stuff. You can also do that. Also, you can track all the history out here, telling that who's done that, why did they do that, when did they really do that, or was any line deleted, was any line added, what exactly it was, and so on and so forth out here, which is difficult to go ahead and do it on a local system out here as such. It is difficult to do it on a local system out here as such out there. Yes, any questions here, guys? Any questions? Any questions, guys?
Normally, we are using this is in the repository. You are directly changing the content on the server, and you are doing a commit, right, Kiran? Here, so normally when we do the changes in the branch, and if you
Hmm.
want to push to the main branch, then we have
Hmm.
some tools, right? How will we connect to that? Suppose source
We'll
tree. If you take a
Yes, we will see that. Again, I am doing a commit directly on the branch. I haven't come down to the topic of branches and explain why do you have to do a commit on a different branch and do something like that. So we'll see that. We'll see that particular concept out here as such.
So we have a feasibility to directly update this on the main branch without lower
Yes,
connecting to the local.
yes, you do. Yes, you do have a feasibility, and that's what I did right now. You can go ahead and do that. Yes, you can do that, but not a recommended practice to do that. I'll also explain why you shouldn't do it and all those things out here as such. Right. So this is a commit, and since I am working with a Git based repository, Git is a software, and I'm working with a repository based out of Git, we call it as a Git commit. So Git commit is just to go ahead and save a file out here as such. Now, what developers or DevOps engineers, what we love to do is that yes, there is a good option to go ahead and let's say do a commit and all that stuff. But if there are multiple files, let's say it's only one file out here in your repository. We normally work with multiple files. We work with a tons of files out here. What we'd like to do is that we'd like to let's say make all our changes and do one commit so that it's easy for me to go ahead and let's say manage all those things out here as such. But with a Git repository, if I go ahead and let's say start editing in a Git repository directly, it's a little difficult to manage my file. It's a little difficult to manage my commits, for which Git will tell you that yes, if needed, you can make a local copy of this repository, meaning you can copy your entire repository into your local system, into your local system out here. You can just go ahead and copy your entire repository out here. And this operation of copy is called as a git clone. It's a clone operation out here called git clone. And since you're working with a git based repository, for you to clone, right, you need two tools. One is called as a, let's say, one is called as git itself. There's a tool called git for Windows. So there's a software called git. You have to download this out. Two is you need an IDE to go ahead and let's say clone this out, or you need a command line to go ahead and do this. So you can do it with the command line ID and all these things. IDs are generally very easier to go ahead and do this. You can use VS Code or Visual Studio. The 2019 that you've downloaded, right? You can use these both out here. We already have VS Code. We already installed VS Code. Let's also see how do you install something called Git for Windows. So just go here, say Git for Windows. You'll have the first link called Git for Windows out here. Just click on the download option. Straightforward installation. Just download this out. Click on install. It'll have multiple options out there. Say next, 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 next blindly and go ahead and install this out. Once you install this out, restart your system and come here. Take Git. You say Git out here. You'll have Git GUI, you have Git Bash, you have Git CMD, you have Git, all these things. This is something that is installed out here. And once it is done, once it's installed and once you restarted your system, come down to your repository. So this is your repository out here. You have an option called what? Clone. Click on this and it's telling how do you want to clone? Where do you want to clone? You have Android Studios, C Lion, Data Grip, Eclipse, multiple, let's say RubyMine, multiple, let's say IDs that are supported out here. But I prefer VS Code, easier, lightweight, and all that stuff. I'll say clone. and as and when I do this, it'll tell, do you want me to open VS Code? I'll say yes, please go ahead, open VS Code. And it's going to go ahead and let's say open my VS Code out here. And it's telling, do you want to allow this extension to clone this out? I'll say yes, open. As and when I do that, it's asking, where do you want to clone? Now, where exactly you want me to go ahead and clone it out? I'll just select a folder called junk, and I'll select repository location. As and when I do this, do you see it's telling, it's cloning the Git repository out here, and I'll say open. And now I have a folder with the name called demo repository. So what Git did is that it went ahead, it created a folder out here called with the name called what? Demo repository, which is the name of my repository out here. And if I go inside this, I have a readme.md file, and very importantly, I have a folder called what? .git. It's a hidden folder, guys. If you want to see this, in my case, I'm able to see this. If you want to see this, go to view, just say show hidden items. In Windows 10, the option also will be slightly different. You'll have view, you'll have, let's say, show hidden items out here. So if I don't have this checked, right, I will not see that particular folder. If I now have this checked out, it's a hidden item in my folder. I'm able to see it. What is the importance of it? What is your hidden folder? What exactly is the importance? Again, this readme file is nothing but a simple text document. It's nothing but a markdown, it's nothing but a text document out here. So if I click here, let's say, I'll say adding one line from my local. I'll do this. I'll save this just like I did earlier. I'm saving this out. But this time there's a difference. What is the difference is that in the left hand side, right, you see a branch kind of, let's say, a symbol. If you click on this, all your changes are being tracked in your local machine as well. All your changes are being tracked in your local machine. This is the advantage of Git. Meaning, not only meaning, if you have a Git installed on your local system, you really don't have to be connected with the central server. So we have two things out here. The repository copy that you have on Azure DevOps is called as a remote repository. The repository copy that you have in your local system is called local repository. So local repository and remote repository out here. So now all your files that are there in your local system, all the changes for this particular file in the local system can also be tracked. All the changes can also be tracked out here. Reason being, you have Git on the local system installed. So on local system you have Git, you can change, you can track all these history. And if you check this out, it's now telling yes, this is the file that is committed, who committed it, and all that stuff. Now I just made a change. I did not commit this out yet. If I want to commit it, there is some an option called stage. Click on this. There is something called as staged changes. Now you see the tree is now gone, telling it okay fine, yes. There's an option called stage, which means before you commit, you are preparing the file to be get to, let's say, to get committed out here. So it's one simple preparation step out here called staging. After that, what I'm going to do is that I'll click here. I'll say this is a change from my local system. This is my commit message on what I'm trying to do, and then say commit. As and when I do that, right, it's now telling yes, the change is committed, and I'm able to see an additional line out here telling adding one line from my local machine out here. My question, guys, is that if I come into the repository, I just have that adding one line out here that I added earlier. Now I added one more line on my local system. If I refresh the screen, will I see the line or will I not see the line? The new line that I added. What do you all think?
We will not. We will
No,
not
No,
see that.
we'll not see that. Why will not see that? If yes, then why will we see that?
We have to push.
You'll have to push. That's what. Guys, please continue, please. Okay, thank you. Yes, you will have to push, or you will have to do a sync. The operation that you go ahead and download the code from the repository, from the remote repository, is called a git clone. The first option that you do here is called a git clone out here. Second operation that I'm talking about is a git push, meaning from my local system, if I am uploading the change back into the repository, this is called as a git push operation. So if I'm giving back something, it's called a git push. So how do I do that? Just click on this again. You either can do a sync, or there are three dots here, right? Click on this and say push. So what this will do is that it will take all the changes from your local system, upload it back into your repository. And if I come here and refresh the screen out, selling, adding one line in my local system, and also very important, not only the line, the history is also being tracked. The history is also being tracked out here. And one quick thing, guys, I forgot to tell you all one quick thing. Very first time when you go and download, or when you go to clone your repository, add a line and try to do a commit. So this is what I'm doing. I downloaded the let's say the repository, or clone the repository. I added a line again. So I'll say added line again. I'll do a control S, save, in order to save this out. And if you check this out, I have one more line. Before I do a commit, what I'm doing, I am staging the change, stage the change, give a commit message telling commit again, and then hit a commit button. The very first time you hit this particular commit button, you will get an error. You will get an error telling me that, okay, fine, please set your credentials. I want you all to try understanding what that error is. How do you resolve that particular error? In tomorrow's session, one of you all have to tell me, how did you resolve that particular error? In my case, I'm not getting an error because I've, let's say, set all my things and all that stuff. In your case, you will get an error. You tell me, how do you resolve that error? So, couple of steps out here. Firstly, clone the repo, make your changes, stage your changes, then commit your changes, and while committing, give a commit message, and finally push the change. So finally, I click on these buttons and say push. I'm uploading the change back again. So git clone and git push, two things that we are seeing out here as such. Yes. Anyone, any questions that I can take till here? Anyone, any questions that I can take till here? All right. So one more thing that I want to now extend is that let's talk about something called as branches. What exactly do you mean by something known as a branch out here? Let's understand what you get with a branch. Branches. See, what do you really mean by a branch is this. Each and every repository system that you create in, let's say, Azure DevOps, or in a Git based repository, to be very general, can have one or multiple branches. One is definitely there. One branch is there. So I say Git. This is the symbol for a branch. So each and every repository system should at least have one branch. at least have one branch out here and have multiple branches. The first branch that gets created in a repository is called as a main branch or a master branch. Main branch out here, this is what we call it as. And I did not create this, it went ahead and created itself out. You can create multiple branches. Why do you even need to create multiple branches out here? What is the necessity for creating multiple branches? Very simple. Maybe I want different versions of my code in order to exist in multiple branches out here. Or maybe I have different teams and I want each and every team to use one individual branch out here as such. But how do you create a branch? No, I'm telling why you create a branch. It's because of you want multiple versions or multiple versions of your code, multiple versions of your file to be holding in different, let's say, branches out here. We'll also talk about in depth about that. But how do you create it? Come here. You have the option here. So you earlier had a drop down here. We can create a new repository. Same way you have the option here. Says new branch. As and when I give a new branch, very importantly, as and when I give a new branch out here, it's going to ask me what is the name of your branch and what is the source branch. Very importantly, if you want to create a branch in a Git-based repository, you will need a source branch out here on the UI. I'm talking about the UI. We'll talk about how do you create the same thing in Visual Studio out here. That's something that we can do. So whenever you want to create a branch, let's say this is test branch. Based on what? Main branch. What this is doing is that it's simply taking the main branch, making a copy of it and calling this as a test branch out here, and both are under the same repository. Both are under the same repository out here. So if I say test branch and I'll say create, now I have a test branch, same contents from the main branch. If I click on the history, same history from the main branch is also carry forwarded into the test branch. So it's not only the files, it's also the history of the file that is carry forwarded out here. And in the left hand side, you are able to see something called what? Branches. If I click on this, main branch and test branch, two different branches that I have. If you want to delete a branch, click on this, just scroll down. You have an option called delete. Permanent deletion. There is no way to recover it out. It's permanently deleted. So as a new branch, once again, I'll say test branch, creating this out from a main branch out here, and I'll say create. So I now have a test branch out here as such. Let's say that in the test branch also I have that particular file called readme.md file, and this file is nothing but a copy that I have from the main branch, right? So it has added a line again and all that stuff. So I'll say one more line I'm adding. I'll say this is a line from a test branch. Let's say commit. I'll say added a line on the test branch. Once I do that, I'll say commit, and now it says added a line on the test branch. Where did we add it, guys? We added this line under the test branch of this particular repository. My question for you all is that now I added a line in the test branch. Does the same line get reflected in main branch? Do you think the same line will get reflected in the main branch out here? Yes, no, maybe. No, yes.
Until we do the commit, it won't
I'm sorry, can you come again, please?
until we do the
Push.
commit operation or push, it won't
Commit operation is already done.
Yeah, push. Can you push?
Push, but
reflect.
push is that's
Push
something that I
her.
need to, let's say do it from a local machine. Git push is something from a local to a remote. But firstly, let's address the question. So I added one line on the test branch. History is also there. Added a line on the test branch just now. Classes Azure DevOps added this out. My question is that do you have the same line in the main branch, and do you have the same history in the main branch? Will you have it or will you not have it? No, yes,
We
here.
don't have.
We don't have. Let's
No.
see that. I'll click on this. I'll say main. And if you check this out, I don't have it at all. I only have it till what? Commit again. The new line that I added called adding a line on the test branch, that is not there, which means though the test branch was created from the main branch, as and when the test branch gets created, these two are individual entities. These two will maintain their own version copies, their own version systems out here until and unless you create or you do a merge operation between your test branch and the main branch. Source, destination. This is called as what? Merge. And in order to create a merge, you need to create, or you need to go ahead, in order to do a merge, I will say in order to do a merge, you need to create something called as a PR, stands for pull request. So changes are not automatically, let's say, propagated from one branch to the other, or changes are not reflected from one branch to the other. You'll have to do a merge for the change to get reflected, and to do a merge you need what? A pull request. This is called as a git merge. Happens through or happens via a pull request. How do I do that? Go back into my repository. In the left hand side I have what? Pull requests. Now it's telling there are no pull requests out here. I'll say new pull request, source and the destination. Destination is by default called as what? Main. Source is what? Test branch. As and when I do that, it's telling this is the commit that I'll add. What is the file change? It's telling there is one change here called this is test branch, and there is one commit that you have added. All these things will be, let's say, committed to, let's say, the main branch out here via a pull request. And I'll say yes, go ahead, create this out. And as and when I create it out, there is something called merge conflict. We'll talk about that. And I'll say approve. I'll say complete. And you have an option to go ahead and delete the test branch after the merge is done. I'll just uncheck this option for now. We'll see why the option comes into picture and all these things. And I'll say complete merge. As and when I do that, I now have a merge pull request out here. It's getting merged out there. It'll take like a minute or so. Once it's done, go into the files, go into readme.md file. I have what? Test line. Also in the history, I have what? Added one line on the test branch. This is also getting, let's say, reflected in the history of what? My main branch out here as such. So that was pull request, meaning when you go ahead and when you create a change or when you make a change on one of the branches and want that change to also get reflected in another branch, we do a git merge, happens through a pull request out here as such. And always guys, remember, any change that happens in your git system should go via a pull request. Why is that? Why exactly is that? Let's see. There is multiple changes that I made on this particular file. In the main branch, there is this file. I made multiple changes. Let's say I want to undo a change, meaning I added line 1. I want to remove that line 1 out here. What I need to do is that firstly, I need to go inside my file. I need to manually go delete this out, make a recommit and all that stuff. But if it comes via a pull request, so this one came via a pull request, I can go into the pull requests, see what is all my completed pull requests. It's telling just completed. I can do a revert. I can push it or I can pull it back, say revert, and it goes ahead, creates a new branch for me. I'll say revert this out. So now what it does is, see, It's identifying what is the commit that you have done using that particular pull request, and it will roll back that particular commit. So for rollbacks and updates of your file, a pull request is always suggested so that you can go ahead and do a revert back of the same thing out here. So I'll say, yes, this is something that I want to revert back. I'll say create this out. I'll say approve. I'll say complete and complete this out. As and when I do that, now if I look at my files, go into the main, I don't have that line called added test line again. If you look at the history, it's telling one change was reverted. And here I have that particular reverted change out here as such. Yes, any questions still here? Anyone, any questions still here on what is a pull request, what exactly this is, and so on and so forth out here as such?
Kiran, what is the use of creating a branch and sub branches? Like, anyways, like they are not until and unless we are publishing, pushing, they are not getting merged.
Yes, exactly, and that's the
Yeah.
exact point.
So
Yes, that's the
we
exact
can
point why I
do
didn't.
the. Yeah. Sorry,
Good,
please.
good. You can
So,
do.
anyways, yeah. Please go ahead.
No, no. You go ahead with the question. I'll continue with that.
Yeah, the reverting of the changes or all those we can do in this sub branch also, no? So what is the creating, why we are creating this main branch and what is the use of it?
Okay. Again, main branch is, let's say, got created by default. I did not create this out. So main branch is
Mhm.
my default branch of my system. So
Okay.
whenever I create, or whenever, let's say, I go ahead and create a repository, I have a main branch out here that got created out here as such. Now, the recommendation here is that keep one branch as a default branch in your repository for all your developmental activities. We'll see that in detail in branching and merging strategies out here. But Git tells you that, okay, fine, keep one branch as a main branch of your repository.
Mm.
Any change that you do on that particular main branch, please approach it via a sub branch so that in case in the future you make a change that was not supposed to be there, you can simply go understand what is a pull request. So for example, let's say this is a change, I reverted it back, I can do another revert again so that to add the change back again into it. So for reverts and updates, it
Mm.
is recommended that we use pull requests out here. And for a pull request to happen, you need another branch. So you need a source, you need a target, right? So that's the reason
Okay.
I've created one more branch and did a pull request. But there is also a concept called branching and merging strategy. Very important. We'll see that in the coming session and understand why do you even require multiple branches? How does an organization maintain this out here as such?
So Kiran, in short, is this sub branches or like snapshots?
Sorry, can you come again, please? Sub branches are like
Uh, snapshots in like
mm,
taking
kind
in Azure or yeah.
kind of. You can compare it that way. Yes, you can do that.
Okay.
You can compare
Okay.
it that way. Yes.
Yeah.
Yes. Any more
Thanks.
questions? Okay. Any more questions, here, guys?
Kiran, yesterday we have created one parallelism, right?
Mm-hmm.
Parallelism request. How we can use that one? What is the purpose of that submitting for that one?
What
And
is the purpose of that one? We will see that purpose when we go into build pipelines. We'll see why parallelism request is really important and where we use that also in the build pipelines. So we'll hold for about 2-3 classes. I need to complete repository. And then once we start with pipelines, I'll tell you why exactly parallelism is important out here as such. Because at this point, even if I introduce that particular concept, it will not make a lot of sense on what is parallelism, why do I want parallelism and all these things. But when we go into a build pipeline, that will help you understand why did we even give that request out here as such. All right, any more questions, guys? Now, let's look at a couple of features out here. So this repository, guys, what I did is that I was able to go ahead clone this repository, make a copy of this particular repository, clone this out. After I clone my repository, I can have two different copies. One in, let's say, the Git based repository, one in my local system. Irrespective whether I have an internet connection or not, I can go ahead and make changes to my local system out here, track changes in my local system, see what is my work and all that stuff, which means that I don't have to be connected to this particular repository out here at all. I can make any changes I can do. Also, I can create multiple branches. We have seen, right? You can have multiple branches, unlimited, no worries at all. All these branches are lightweighted branches. They are nothing but versions of the main branch out here. So branches can also be created, and you can make a clone of your repository, work offline and all these things. All these features are a feature of something called as a distributed version control mechanism. All these are the advantages of something known as a distributed version control mechanism. Version control mechanism. I think I've got the spelling wrong for distributed. Let's correct this out. Okay, distrusted, not distrusted. Distributed is what I want to type in. Yes. Distributed version control mechanism. So version control mechanisms are normally classified into two types. One is called a distributed. Example of a distributed version control mechanism, Git. You have something called a Bitbucket. All these are distributed version control mechanisms out here. And opposite to that, you have something called as centralized version control mechanisms. Very, very, very less used. Centralized version control mechanism, or centralized, please correct this as centralized, not central. Centralized version control mechanisms out here. So centralized version control mechanism tells one thing, is that you cannot, or you can make a copy out here. You still can make a copy, but for you to make any change, you always have to be connected to the internet. Also, you cannot go ahead and create multiple branches out here. Branches are heavy weighted out here as such. So multiple disadvantages of a centralized version control mechanism. Examples, you have something called TFVC, Team Foundation Version Control, and you have something called SVN, Subversion, called subversion. So these two are examples of a centralized version control mechanism. And I am working with a distributed version control mechanism. Can I work with a centralized version control mechanism for some reason? Definitely yes. But you have to select that when at the time of creating a project. So if I'm saying create the project out here, I'll say sample. You have something called what? Private. If I say advanced, it's now asking what is the version control? Is it Git or is it Team Foundation version control out here? And I'm finding it a little hard time to, let's say, compare this out. Click on this. It'll tell you choose the right version control for your project. Which version control system that I need to do? Git is called what? Distributed, TFVC, centralized. Just scroll down. This is what it will tell you. Team members can concurrently change on the local machine, keep a keep a track on the local machine, all these things out. And here it's telling that, you know what, you'll need an internet, you'll always need to be online out here as such. And there are a couple of examples, or a couple of, let's say, things out here. And there are a couple of comparisons out here that you can kind of read about this. Sorry. Yes, differences between TFVC, meaning a distributed versus a centralized version control mechanism out here. So this is important. I would just like you all to go ahead and, let's say, give it a read. TFVC is not being used these days a lot, or centralized version control mechanisms. Out of every 100 projects, 99.99% projects will use Git or some kind of a central or some kind of a distributed version control mechanism. Very less, very, very, very less where you really need a control, where you need, let's say, control out there. Even in those cases, they are not really using TFAC. Very less projects they use, let's say, a centralized version. You just have to understand the difference between them. Yes, any questions here, guys? Anyone, any questions out here? Anyone, any questions that I can take? So what I wanted to do today is just play around with the basic operations. So all I wanted to do today is that yesterday I started with introduction. Today I'm just giving some basic terminology like what is a repository, what is a branch inside a repository, what is commit, what is clone, what is push, what is pull request. Also, please make sure to download the Git for Windows tool. And as I said, the very first time that you are going to get an error, do a Google search. Tell what is this error? Why am I getting this error? See what is the recommendation, see how you can resolve that particular error, and let me know out here as to how do you resolve that error, what would you do with that particular error out here as such. All right, any questions, guys, before I close? Anyone, any questions? Okay, let's see. Do we give permissions to every member to create branches? Depends upon what kind of a permissions they are, and I'll also show you how to add members and how to give them the permissions out here as such. But usually if it's a developer, we give them, yes, we give them permissions to go ahead and create their branches. It's important for them depending upon the software development lifecycle that you really follow out here as such.
Kiran, while making the changes in a Git and before it commits, whenever that power shutdown it happens, you said once you commit, then only it's save, right?
Mm-hmm.
Once the any while you're making the any changes while the power cut happen means it's almost all things gone. It auto
All
save.
these changes will be there on your local machine. It won't get committed to, let's say, the repository. It will be on your local machine. Once you, let's say, get the power back and once you are connected online, you can go ahead and, let's say, push the change back again. So it's not lost. It's there on your local. There's always a copy of your local system that you can use out here as such. Yes, any more questions, guys? All right, so that's it from mine today. I want to keep it a little light to understand what are the basic terminologies. Tomorrow we'll expand that. We'll see more
Kiran,
on, let's say, repositories. We'll
can we use Git Bash instead of VS Code?
yes, you can do Git Bash instead of, let's say, VS Code. But if you have VS Code, uh, what is the need of Git Bash? I mean, you can do Git Bash. You can do additional things with Git Bash, of course. Yes, you can do Git Bash. You can also do Git Bash in VS Code also. It's a terminal. You can say new terminal, and I can choose a Git-based terminal out here. I can do a Git Bash. Yes, I can do that. So I get a Bash terminal. I can do all my commands out here as such.
Yeah.
All right. Thank you guys, and have a good day. Thank you.